cloud.
Okay.
All right.
Yeah, so I'm going to go ahead and share my screen. Let me get this, let's see, get this stuff moved over here. Get these things out of the way. I don't know if I can move your screen sharing. Don't know if there's a way to remove that or not.
I'm trying to remove.
Let's see. Oh, cool. Yeah, that's what I want to do is get it over here on my second screen. I guess that one can't move. All right. Yeah, that one looks like it's stuck there. So, yeah, I'll go ahead and start this demo. We're going to actually do, if this all works out the way I intended it for it to, we're going to actually do a full live demo. So I have a SIR file that I recorded on February 15th, and you can actually load that up as a camera. So here in SharpCap, kind of the way SharpCap works is you don't see a whole heck of a lot of anything in SharpCap until you connect a camera. And right now I'm on my desktop PC. So, obviously there's nothing connected to this, no astrophotography equipment or anything connected to this. So you might be wondering how in the heck are we going to do a demo there? But you have this feature in SharpCap where you can connect a test camera. And I wish I could tell you that I took that picture of Jupiter. I did not. That's that SharpCap is good, but it's not that good. So that's just kind of a default picture that's in there. But what you can do is browse to any files on your hard drive. And so I've saved a SIR file. There's a couple of them that I have here that I recorded on February 15th. And we're going to use this one. So that's actual footage that I took of Jupiter on that night. Just happened to be a clear night. In fact, I thought I was through with Jupiter. I thought, I've recorded all I need of Jupiter and thought I was through, and then saw that this one night was super clear and knew that I was going to be presenting. I actually was originally going to be presenting at the main meetings. And then Andy, you had asked that I present here as well. So I'm kind of going to be presenting this twice, but the one at the main meeting will be a little bit different. It'll have some PowerPoint slides and stuff. I'm going to skip the PowerPoint slides here because I think all you guys are already past that. It's kind of like fundamental stuff for people that maybe haven't gotten into Planetary yet. So I kind of start slow with that one. So instead for this one, I think we can just jump right into the demo. And but the thing with this demo is that even though this is great that we have this live data here, we still don't have everything because I don't have a mount connected here, so you're not seeing the mount, you're not seeing my focus or anything like that. So that's the reason I have my telescope behind me, is because we're going to use kind of a combination. So now this right here is my remote session that I'm moving around here. So you can see my desktop in the background, but this is the actual remote session on the computer. In fact, if I were to minimize this and also the stellarium that I have up here, you can see this is just a regular Windows desktop, all the usual things that you normally see in Windows. That's exactly, it's just a Windows 11 PC that we have there. So the reason I wanted to have both is because, now if we get into as we're talking through this conversation, there may be certain points where we may want to point to certain features and things, like related to where the mount is and my focuser and things like that. So we may switch back and forth between these a little bit. Hopefully that won't confuse everybody. I'll try to let you know when I am switching. And then, hopefully everybody will stay with me and know where we are on this. And so what I thought I would start with is just showing, we'll just kind of step through what we all do when we're imaging. So the very first thing, of course, we're going to assume that the polar alignment's already been done. And so the first step is to slew to the target, right? So you can do that here through SharpCap. SharpCap has its ability, it has go-to functions built into it. So we can go through here and, go ahead and type Jupiter and pick it. And if I clicked start here, it would go ahead and slew to that. And then it would do a plate solve to center it. So we could do that. But I actually prefer to just do this through Stellarium because the cool thing about, so I'm going to just hit the space bar to center on that. I just like starting here because, you can zoom in on the planet and get a sense of, what position is the planet in? Are we going to see the red spot? Looks like we are. If we were going to actually image tonight, we would know right away what we're about to see. And a lot of times I'll go ahead and fast forward the clock so we can just see what moons might be crossing over. Looks like tonight we won't really see a lot in the way of moons. So, but at least you could see here that you do have the red spot coming across here. So I just kind of like to start here with this. Let me back up to where it was. Get pretty close to what our current time is. I think if I go to complete current time, it'll be just kind of right around the daylight there. So we'll just stop it right about there. And then I'll go ahead and back out here. And with that selected, I can press Control-0, which brings up this slew function here. And then I just click on current object, and then it goes ahead and puts in the right ascension and declination coordinates. And then I go ahead and click slew on that. So if you look over my shoulder there, you'll see my mount is going ahead and moving to that. And since this is ASCOM based, ASCOM shares all of its information. You can see it's already sending the coordinates to SharpCap over here. And if I switch back over here, I don't know if you saw that icon moving in. That's the mount coming over and syncing up with Jupiter there. So we have completed the slew. And at this point, there's not really much else to do with Stellarium. Stellarium is mostly, just planetarium software, but it does have, this ability to, to slew to your target if you want to. But once you've done that, then you need to get back into your imaging software to do whatever imaging that you want to do. And sort of the last good thing to do at this point would be to plate solve, because, anytime you're slewing, you're getting in the ballpark, but you're not dead center on the target. So then the last thing you would want to do is plate solve. And that's what this little circle is here. It looks almost like a traffic circle in London, with the roundabout thing. And that will do the plate solve. And if my telescope wasn't looking at my ceiling right now, you would see Jupiter come, right into the field of view there. So that's what we've done so far is so now we've moved the telescope to our target, and it's a good idea then we'll just quickly go through. We don't have to go into a lot of detail here, but I'll just kind of spin through these options here. So the first thing is to set your capture formats. Usually you want to be at RAW 8 for imaging planetary. There's other people that might argue that point, but I've always done it in RAW 8. And then you choose whatever ROI you want to go in. So, with planetary, the smaller the better for the ROI, because you're getting a better frame rate because you're not capturing as much outside of the planet there. But usually you start with the full frame size until you get the planet centered and you kind of have your bearings and where you are and stuff like that. And then, once you're locked onto it, you can pick whatever ROI size you want at that point. This is the SURF file is actually what we have opened right now on the other screen. That's what's showing that video of Jupiter. So that's just the kind of the default video format for planetary. And the interesting thing about this is I usually, when I'm doing live stacking through SharpCap, this is one of the things that's kind of unique about SharpCap, I don't even save the video half the time because I'm live stacking on the fly and generating the photo and stacking and sharpening and doing all those functions that we normally do offline. I'm doing on the fly, so half the time I don't even save a SURF file. But I did in this case because I knew I was going to want to come back to the recording for it and do the demo. So anyway, just kind of a long way of saying, that's the default format for video if you are going to be doing video. And then camera controls, this is probably the more important one. I know that last time we were here. I think Mark was hoping to get some, I guess he's not in the meeting today, but I think he was hoping to get some information on how to set these settings. So we'll be going through that in the other screen where we actually have the live demo of Jupiter up. But just to show you that that setting is there. So it's just a matter of getting the right combination of exposure and gain. And then not a whole lot else in that screen that I normally mess with. And then the display histogram, this is used quite a bit. This helps you determine if those settings are right, your exposure and your gain. I kind of use two methods for that, kind of eyeball it and see how the planet looks, but then also make sure this histogram is not maxed out one way or the other. So I use that histogram. And then here's the telescope controls. This is handy because with Planetary, you're using such a small ROI. The planet is going to drift a little bit unless you have some really, good guiding going on or something. And we'll be talking about that too. Um, it's going to drift a little bit. So you're going to need these controls here to kind of put your planet back on center. You can use the field of view to do that, the ROI, but your sensor is only so big, and that'll make more sense when we get over on the live demo with the planet. So anyway, that's the controls. I do end up using those just to keep the planet kind of centered. I don't do a whole lot with this because you can control this stuff after the fact, with your image editing software. So this is kind of optional here if you want to do it. And let me see, is there anything here? I don't really do much with this section either. Pre-processing, the only thing I turn on here is planet disk stabilization. So if you turn that on, that'll help keep the planet kind of solid and without shimmering around so much. So that's one that I will be using. Okay, so I think that is about what we want to show so far for that one. And then, so we'll minimize this and let's see, minimize this. Actually, uh, let's see, flip over here to what I need to do is get back to, oh, there we go. Yeah, I guess I've already got it minimized. Okay, so so where we are is we've slewed to the target, and so here we are with Jupiter. You can see it kind of jittering around there a little bit, and so we'll start going through these controls, like I said, on the other screen. So we've got this set the way we want it. The one thing I wanted to show you here, you might be wondering, why is 800 by 600 the very highest ROI that we have? That's just because that's what I recorded it in. If I had this to do over, I probably would have recorded in a higher ROI so that we would have more flexibility. But I mean, we could go down, but we can't go up. So if I go down, you can see the planet in a smaller ROI there, and I can move this around. You can use this centering button to keep it centered. And so this is one of the things that I was doing when I was doing longer, because if you're doing time lapse, you're recording for like 4 hours, so you really have to stay on top of this. And I was saying track ROI. I think it was yeah, track region of interest and track it in center. And so what I would do is just let this sort of, if the planet was getting off center, this would move for me and stay over the planet. But of course, after a while, you start to run out of sensor space. And then if you get to the edge and you don't catch it right away, it could get so far off the edge that you kind of lose track of where it is. So that's why it's, kind of important to have pretty good polar alignment so that you're not always having to make so many adjustments. And that's only true if you're going to be doing this for a long time. If all you're looking for is a still shot, that's only a 2-minute video. You're going to make your picture quicker there. You don't really have to worry about polar alignment or guiding or any of those things if all you're looking for is a quick still shot. But it's a kind of a different ball game if you're trying to do the time lapses because you got to stay on it for about 4 hours to really capture enough data there. So let me get this back to where that was for now, because I think that's where we want to be. And then under camera control. So this is probably maybe the most important thing to tell people. This is just sort of a balancing act. This is you're trying to balance the desire to have a high frame rate. So if you, can you see my mouse down here in the lower left-hand corner? Are you able to see that?
Yeah.
My mouse moving? I don't know if you were able to see that down there, but anyway, the frame rate is showing down in this lower left-hand corner.
Yeah,
And
it's
so
showing.
Okay, good. Yeah. So it's kind of a balance here. If you turn this way, way down here, you're going to get a higher frame rate, but then that means you have to turn up the gain more. And so when I'm deciding how to set these settings, I'm partly looking at the planet and does it look good? And then I'm partly looking at my histogram here because the two of those together can help you determine, if you're in the right spot. That histogram should be right around 80%. So that's where you see that histogram right now is just about right. Um, but if I were to, and so if you look down here now, I'm getting 97 frames per second, which is pretty good. I feel like anything 60 or above, I've been getting good results from. Um, but some people are really hell bent on getting the highest frame rate they possibly can, and if that's what you want to do, then you're probably going to be down here in the lower section of these exposures, which means you're going to be at higher gain. So you can see, in order for me to be in the right spot with that 10-second milliseconds exposure, I got to have a pretty high gain, which is not so good for noise. So for me, I tend to prefer to be right around 16 milliseconds. That allows me, and now you can see I'm blowing it out. So now that means I got to pull my gain back down here. And so there I am at about 80% there. Now I'm at
Russ.
296 gain. Yeah.
So isn't this kind of like camera dependent? What kind of camera you're running, and um, so I mean, what kind of camera do you have for this?
I have a Planetary 585, an ASI 585. So yeah, it definitely does depend on the camera. In this case, this software is trying to do the best it can to simulate it because we're not on the actual rig right now. The actual rig is down here. But
Yeah.
this is doing, just sort of a simulation, and this is just giving you the general idea. But you're absolutely right, Andy. I mean, a different camera is going to have different settings, and there's no way to tell anybody, exactly how to set this. But the whole point being is that there's a trade-off. That if you go to a higher exposure, let's say we go all the way up here to maybe 30, some people even go up to near 50. Now we've got it blowing out, and that means we can pull this gain way down. So here we are now at like only 140 gain. So it kind of depends on what you're after. If you're worried about noise, you might want to, have this set up at a, higher exposure rate, maybe around 30 seconds, and then you can pull your gain down. But just be aware of what's happening to your frame rate down here in the lower left. Now we're down to 32 frames per second. And that's probably too low. That's probably not really enough frames for Planetary because the whole idea of having the high frame rate is is to catch this sort of shimmering that's happening with scene conditions. And so with these scene conditions, they're shimmering in and out, a millisecond at a time. 1 millisecond might be good scene, the next millisecond might be bad scene, but only for that specific millisecond in time. So the faster frame rate you have, the more your chances are of catching some of those brief moments in time when the scene is good, then you snap a shot of it, while the video is running. So that's probably all I need to say about that. Is just be aware this is a trade-off. I'm going to put it down to, this is about where I had it for mine, and then I would put this gain for right here. I was kind of at around 16 milliseconds when I was doing mine. But again, completely up to you, and it's all dependent on what is important to you. So I think that is it for that section. We're going to close this. This test controls is not something you would see in a normal session. These test controls is how I loaded up the video. So this is really more for demo purposes. So I think we can turn this off. But as you can see, that's the progress bar running. So this is about a 2-minute video. We're almost at the end of the 2-minute video, and it's going to automatically loop around. We won't even notice the delay when it loops back around. But you can see that I have about 14,000 frames in this video. So we'll continue to let that run while we're working with this. And then image controls, nothing to do there. Pre-processing, this is where you can turn the planet destabilization on or off. I have it on right here. And I think it's behaving a little bit differently because I had it on in the recording. So normally you would see like a little red line right here that's kind of moving the frame around. That's part of how it helps keep it stabilized. So it's probably behaving a little bit differently because it's a video, but for the most part, I think this video is giving us a very realistic experience. I mean, this is what I was seeing the night that I recorded it. So I think SharpCap doesn't really distinguish that much. It just wants a video feed, and it doesn't care whether that video feed is coming in live or from the SURF file. So we're kind of seeing the same thing that I was on that night. Okay, and so I think that pretty much got through all those settings. So now that we have everything set the way we want, we go ahead and start the live stack. Now, this is one area where you want to kind of be careful here because, and I wish I could move this bar that I have here. Let me pull this down. I'm just going to go unmaximized here for just a minute. Because this live stack right here, that's for doing DSO live stack. So that's not the one that you want. This one with the little icon of the planet, that is the one that you want. And watch how quickly it starts resolving the planet. I mean, just the minute you click it, it's already starting to stack the planet and give you better resolution. Actually, before I do this though, let me stop this for just a bit because I think I kind of skipped ahead a little bit. The one other part is focus. That, you know, obviously once you get centered on your target, you obviously would want to focus, and focus is quite a bit different in Planetary than it is in DSO, because with DSO you're just picking any random star to focus on, and as long as those stars are small and sharp, you know, with your what is it, HFR and HFD settings, you know, that you're getting a nice small ranking on the star size, then you're good for DSO. But with Planetary, you don't do it that way. And so it uses this, if we go into Focus Assistant here, it uses this thing called contrast edge detection. So you can see what it's done here is we built this border around so that we're not focusing the entire chip, the entire sensor. We pick and I could make this border smaller if I want to, but usually that's fine right there is the default. But the thing to notice here is this black border around the planet. And I can make that border bigger if I want, if I change this slider down here, but I've always found set right here at 10 is just about right. As long as it has this black border to create this contrast, what it's looking for is how smooth the edges are around the edge of the planet here. So that's the way you focus in Planetary. So the rest of it is pretty much the same in terms of how the focuser, goes in and out, goes far left and then far right, and checks different focus positions. So your bell curve is still going to look very much the same. It's just that it's using different data to different points of interest on your picture to focus from. And the other side of this too, and we should probably. Are all of you familiar with the overshoot method of setting your backlash? So we all know that backlash is important. We all have backlash in our focusers, and we have to compensate for that backlash in one way or another. I was just wondering, does everybody know about the overshoot method, and is that what you're using?
No,
Yeah,
not.
Oh, yeah, that's what I do, Don. Yeah.
Okay, so we've got some nose.
I'm using the same settings, what as close as I can get to what I use on the ASI Air for deep sky stuff.
Okay.
So
Um, if there's some people here that are not familiar with the overshoot method, I think I should talk about that real quick. Because there are some advantages to it. It's not a do or die thing. You don't have to do it that way. Um, but let me just bring this up here. So this is just this is actually a screenshot out of my main presentation that I'll be doing in April. But this is one screenshot out of that presentation. I thought it might be worth us discussing. So people adjust for their backlash in all sorts of ways. One way you could do it is to. I wish I probably should have taken my refractor out here with me so I could hold it up and show it. But what some people do is just literally make a little line on their focus knob. It's kind of a primitive way of doing it, but it's effective. And then they go ahead and rotate that focus knob, let's say a good half turn, so that it's, that they've moved it into a negative direction. And with that little line, from a marker on their focus knob, now they go to their controller, whether that's a hand controller or maybe your ASI Air or whatever it is, and start hitting the up arrow. And of course, you take note of what your step size is. Let's say your software has set your step size for 10. So now you hit your up arrow. 1, did it move? Nope. Again, did it move? Nope. Now we're at 20 because the step size is 10. Hit it a third time. Now we're at 30. Nope, still didn't move. Hit it again. Nope. Hit it again. Nope. Hit it again. Oh, there, it finally moved. So let's say you had to hit it 5 times with a step size of 10. Now you know your backlash is 50. So that's one way of doing it. That's kind of a primitive way of doing it. I actually think a better way is to just be aware of your bell curve. So whenever you're doing autofocus, you have your software bell curve is in front of you all the time anyway. That's what's up on the screen as your autofocus routine is running. And so just we know that this flat area here, the healthy part of this bell curve is the V shape. And then whenever you have this flat area, we know that that's the backlash there. And most of the software is going to have these numbers down here to show what the increment size is. So you can see I have 9,900 here, then 10,000, then 10,100. So we know that each of these sections is 100. And so from here to here is 200. But the flat part of this graph is not actually going all the way to each end. You can see it stopping short of each end by just a little bit. So I would estimate that to be around 160, maybe 170, something like that. That's how much backlash we would have here. And so if you wanted to do it the old traditional way, you would use this third radio button here, the one just above my yellow highlight. You can tell my yellow highlight is preferencing the overshoot method, obviously, but for now, we'll talk about the original method. Is you would just choose this third radio button, and you would simply put in that exact amount of backlash in there. We said we thought it was around 170. So now the software is going to automatically compensate for that, and when you're moving back and forth with your focuser, it'll go ahead and take care of that. But the better way, or I shouldn't say better, my preference, and I don't know, maybe not everybody's the same, but I just would rather not have to calculate the backlash that exactly. Instead of calculating it exactly, you just say, okay, well, look, I know it's around 170. So let's go ahead and overshoot by a much larger number than that. Like I have it set at 200 here. That's actually probably kind of close because if you were off a little bit, that doesn't leave much margin for error. So you could go as high as 400 or even higher than that, because that might sound like a lot of steps, but 400 steps on a ZWO autofocuser is maybe a quarter turn. It is a tiny, tiny little bit. So don't worry about, oh gosh, if I use too big of a number, is it going to slow down my autofocus routine? I can guarantee you it won't. That's not even a detectable delay that you'll see there. So if you're going to use this this overshoot method, I would say overshoot by double whatever you think your backlash is, and then you'll be in good shape. And then you also define here what direction you want to return in. So if you want to return in the positive direction, then you're always overshooting in the negative direction. Now you could reverse that if you want. You could overshoot in the positive direction and return in the negative if you wanted. But I've heard people say that it's better with some SCTs in particular, something about how the way the mirror is set up inside, that you always want to come back with a counterclockwise motion, which I believe is positive. I don't know if that's true. It's probably splitting hairs, may not really matter that much. But I believe that the best thing you can do is overshoot negative and come back positive.
Yeah, I would say I normally do the overshoot, and I'm manually focusing, but from a machining perspective, whenever I'm on a manual piece of equipment, to do anything precision, you even on a Bridgeport mill or something, you always have that backlash. So you always have to make sure you're going the same direction doing it, so it's actually at the right spot.
Yeah. So the whole idea being is that by the time you go way out here, let's say 400 steps, it's coming back in. And by the time it gets back in here, it's already absorbed all of that backslash long before it gets to this point here. Here's the red dot where, in this particular demo example, that's the focus point that it's decided is the optimal focus point. So long before it gets back there, it will have already absorbed all of the backlash there. So that's all I have to say about that. So, getting back here then to, this focus, we can go ahead and run. So let's move back over to my actual rig for just a minute. And I'm going to pull up SharpCap here, and we'll look at, let's see, where is... Oh, there's the focus. I was looking for the focus. I thought it had its own section. I guess it's in there with the mount. That's why I was a little confused there. But anyway, what SharpCap is kind of funny about this. You want to be actually out of focus first for this. Let me see here if I can pull this back. So what you want to do is go, the focus that we have on Jupiter right now is pretty much in focus. And for some reason, SharpCap, it's kind of counterintuitive. Whenever I'm using my ASI Air or something, I always try to make it as easy as I can on the ASI Air and get it as focused as I believe it should be by eye. And then the ASI Air can take it from there. But this is kind of different, where if you're already in focus, SharpCap doesn't like that. I've had the autofocus routine fail every time I've done that. So what SharpCap wants you to do is hit this negative button about 5 times. Well, depending on what your step size is here, I have it set for 250. But you hit this about 5 or 6 times and get it out of focus, and then when you're back over, let's see, let me get back here where we were. Oops, I think I accidentally clicked PHD2. I hope that doesn't start. Let's see. I think we're back here. Okay. Yeah, I guess focus routine just got out of focus assistant, contrast edge detection. Let's see what's going on. Am I on? Oh, I'm on.
Yeah, you're on your remote. Right?
Yeah, exactly. The reason I'm having trouble switching this, it's this bar in front of me is kind of hard to work it around. There we go.
Yeah.
Yeah, it's getting right in the way of what I'm trying to click on. I'll have to figure out that sometime. But anyway, So what I showed you before on the other screen, you get into the negative zone, and then over here is where you focus. You said focus scan in the positive direction since we were negative before. So I'm going to go ahead and run this for just a few seconds. We're not going to run it all the way through because focus routines take a while, but this will just give you an idea of what's going on. It's doing the same kind of thing that you're probably used to seeing in DSO, where it's checking different focus positions and plotting the results. And but instead of plotting the size of the star, it's plotting the smoothness of the edge of the planet there. So if we let this run long enough, this would create its own little bell curve, and it would find the focus position. And then because we have overshoot set up, it would go way off to one side and then come back in from the positive direction. So I will go ahead and stop that. Let's see. And you can see I'm out of focus here now because we allowed that focus to run for a little while. So I'm just going to go back here. There's a thing called focus offset. This is sort of a software version of imitating focus. So I'm going to set this back to 0, just so that we have a nice focused planet again. Okay, so now that we got past the focus stuff, this is where I was starting to go before. I kind of got ahead of myself a little bit, but now we want to go ahead and start the live stack. And this is pretty cool. I mean, you see how quickly it already has the planet looking better. Now over here on the left, you see this slider bar here? This is where you decide how large the target stack is going to be. And this number right here that I'm highlighting, once that matches this number, then it's reached the full stack size. And at that point, it's kind of a first in, first out method. Whatever frame is expired, then the new frame comes in to replace it. So right now, nothing's being replaced because we haven't maxed out the frame size yet. And you can slide this bar, to wherever you want it to be. I usually keep it right around 2,000 stack length.
And is that always with a 14-minute or 14,000 stack? I mean, how do you decide?
So yeah, there is 14,000 frames in the stack, so it will eventually get through all of those, but in my case, I'm usually not even working with a SIR file. I'm just doing this live. So it would be, however I want it to go. But in this case, we're working on a 2-minute SIR file, which has 14,000 frames in it. And yes, it will go through all 14,000 of those, even though I have this set to 2095. Once it reaches the, and are we there? Yep, we just reached it just this second. So this number here now matches this number up here, which means that it's full. And now it's replacing frames, so any new frames that are coming in, it's like a first in, first out methodology. Now, I haven't even done any sharpening yet. So there is this function here where you can click auto sharpen and it kind of sets things, but look how clean it's already getting. And then you can also set up, this side is for your colors and stuff, how much saturation do you want? So we can slide this back and forth to get, whatever looks right for you. I always feel like the planet looks something like that. And then, you've got all these, the reds and everything that you can use there. We have gamma control, which kind of helps if there's any ringing going on. That helps with that. And then usually under this fine adjustment, this is a very sensitive adjustment. If you put too much on this, you can get too much noise on your planet. So I click it up to about 0.3. And then the rest of this is just, it's kind of eyeballing it. If I went way too far, you see how that looks terrible, because I'm way too much sharpening there. And so each of these, the further you go down, the more sensitive these sliders are. So if you put this over there, things get really crazy. So, this is a lot of this is just judgment, how do you think it looks? And if you really mess things up, you can always hit the auto sharpen button again. You can also go into expert mode and then you really have a lot more controls. This probably looks a little bit more like Registax to people who are familiar with Registax. So, you can turn that expert button on if you want. And then you can also, reset everything. If you don't like what you've done, you can even reset the stack. So now we're starting like completely fresh with the stack all over again. So let's see here. Yeah, there we go. So now it's almost like I just turned it on again. And notice that the increment down here is only in the 300s now because I just reset the stack. So it's going to take a while again before it gets back up to this 2095. So every time you reset the stack, it's like, you know, reset button. You're starting all over again. But once you get this to where you like it, let's go ahead and set these back again. I'm not going to spend a lot of time doing this, just kind of get it roughly where it seems right. About like that. A little bit of gamma control maybe. And it's, you know, it's still stacking. We aren't at the full stack here yet. It's still building up. It kind of paused there for a little bit. And now it's picking back up again. But anyway, point being is that once you've done this and you decide you like it, you just click this button right here and it creates the PNG file. Now we have this PNG file on our hard drive. There's your picture of Jupiter. Or you could do it as a TIFF file. Click this TIFF file right here. There's the picture, and these are, you know, pictures actually getting saved, you know, to my hard drive here. We can go over here. I'm just going to kind of zip through some of these tabs here so you can see. This will look familiar to you from AutoStacker standpoint. So this is doing the frame filtering. So, you know, a lot of these things are the same features. It's just a little bit different format, you know, a different interface. But you'll be familiar if you're familiar with Planetary. You'll certainly be familiar with frame filtering and setting this value to, you know, how many frames do you want. You know, if it's a pretty good night, you know, 50% is probably not a bad number. If seed was really bad, you might bring this down to 20% and say, no, I only want to keep, you know, 20% of the frames of the really good ones. So this varies, but I've been finding, for the most part, I don't know what the rest of you guys think, but it seems like 50% is a pretty average number. You know, if you have reasonably good conditions, you're going to have, you know, 50% of your frames that are salvageable. But, you know, obviously that varies all the time. So what else do I want to show you here? I'm going to skip the time lapse button because we're going to do that at the very end. We're going to actually create a time lapse here in this demo. So we'll do that, but we'll come back to that. And then the stabilization and alignment buttons, you know, for planets, you want to set that to planetary. If we were doing the moon, you'd want to set that to surface because, you know, it would pick up on features on the moon, and that would help you there. But in terms of planetary, you usually want to set that to planet full disk. And then these are the stacking modes. So just like in AutoStacker, where you have your alignment points that you set up, where you have single point or multi-point, this is doing that for you. So I have this set to multi-point right now. And it's not asking us to define those alignment points ourselves. So that's one of the things it's kind of doing for us that you don't have to do. And then, you know, the rest of these, you know, tracking the planet within the selection area, track within the ROI. Those are, you know, options that you can turn on or off as needed. You can flip it horizontally if you want. You can see I'm flipping things around here. Flip it vertical if you want. Again, I usually do that in post-processing, but you can, and you can also rotate it. There's a rotate 90 degrees. That's actually probably the more correct orientation right there. So you could do that. And then also you can do this kind of half and half thing that shows, you know, what the raw data looks like. Click it again and show the other half over here. Or I could just turn it off altogether and, you know, shows you what the raw data looks like without any stacking. So there's, you know, a few things that you can experiment with there. This tab, I've never used this myself, but I kind of have the gist of what it's doing here. This is basically doing an auto capture of frames based on conditions. So sort of like how we have the frame filtering that is saying, 50% of the frames are good or 50% are bad and drop them and whatever. This is actually saving the data based on those conditions. So I haven't actually tried to use this yet, but this is sort of a conditional thing where you can do an auto capture based on whatever quality settings you want to set up in here. So it's kind of cool. Looks like you can do some cool things with that. And then these are just settings to save your settings. So let's say, let's go ahead and save this first one, and that's called Planetary 1. Now, if I went over here and then deliberately screwed this up, let's say we really messed that up bad, and then I can load that to Planetary number 2. If I wanted to come back to my original settings, I can just load this right back up here. If I load this one back up here, it's going to go back to the original thing. So what you're doing here is you're saving these settings across the top here. Nothing in here is getting saved. These are all more like capture settings and stuff like that. But when you do these save buttons here, you're essentially just saving whatever you've configured in these top tabs here. So that's what's going on there. We'll put that back into a better position there. And yeah, let's sharpen this up a little bit better than that. Yeah. So let's see. We'll bring this one up a few. I think that will help. And then usually back that down a little bit. Okay. Yeah, I mean, that's a pretty darn good looking picture of Jupiter right there. And can adjust the gamma a little bit to bring that down. I mean, I'm seeing some pretty good definition there. So this is a case where, I would go ahead and save the PNG file, and then that would be my picture of Jupiter that I would share with friends. So that is pretty much everything on the still picture side of things. But if we want to do a time lapse, so normally this would be, so I'm going to kind of walk you through what has to be done to do this time lapse. Normally that would be set at 30 seconds. I was doing my time lapses at 30 seconds. And I think that's probably about the right number to use for Jupiter, because Jupiter spins so fast. Other planets like Mars, I actually haven't time-lapsed anything else other than Jupiter, so I don't know this for sure, but I'm guessing that for Mars, since it rotates slower, I would probably want to use a larger number here, like 60 seconds, so that we get that rotation a little faster. But, you can also just take it into your video software and increase the speed in there too. So you almost can't go wrong with whatever you set here. But for Jupiter, I was doing 30 seconds, and I kind of liked that result. I liked this kind of slow rotation that it provided. I didn't want it to be too fast, didn't want it to be so slow that you can't see it. So I liked that. And then the other thing that I really like doing, you can go ahead and set this to AVI, and when you do your time lapse, it'll automatically already be ready for you as an AVI file. As soon as you stop the time lapse, you'll go look for the AVI file that it saved, and you'll see your rotation there. I kind of prefer to do it myself though, because I prefer to save these individual PNG files, and then we're going to use a tool called pip that will combine all those PNG files and then help you create that sense of rotation there. And the reason I prefer that is because I also like still pictures. I don't want just the time lapse. I also want to have some cool still pictures. And so just imagine how many still pictures you're going to end up with in a 4-hour time lapse. You're going to end up with, I don't know if it's hundreds or thousands, but I mean, it is a lot of still pictures. And I can guarantee you, as you go through those still shots, you find some that you like better than others. So you end up with, as it is, the frame filtering is already picking out the best frames. So it's already kind of done it for you. But then on top of that, you're then taking the best of the best of those frames, because now you're picking out your favorite PNG file from all of that. So that's why I like to do it, but maybe everybody's different. You might want to do it and just go straight to the AVI. But what I'm going to do for the sake of this demo, I'm going to switch this to 3 seconds just because I don't want us to all have to wait 30 seconds to see each of them come through. So we'll set that for 3 seconds. Oops, my goodness. I got a little crazy with my mouse there. And then the rest of this, once you've made these settings, there's not a whole lot else we have to set. So I'm going to start the time lapse. And then I'm going to switch over to the directory where that is. So today is the 17th. That means open this folder the 17th. And we have a few folders here. So what time is it? It's 7:51. So here is 7:51. So this must be the folder where all of them are coming in live. So we're going to shoot details, and every 3 seconds, you're going to see a PNG file show up in there. So this is where I was kind of telling you, now you have all these individual pictures. You can double click each one of these. There's the picture from that one. There's the picture from this one. They might all look identical to you, but I can promise you, as you scroll through these, you will see some that you like better than others. So that's what I like about doing the time lapse manually. If we just went straight to an AVI file, sure, it'll be less work and you'll have your time lapse quicker. But I kind of just like the flexibility that we have all these still shots as well. Okay, so I'm going to minimize this. You get the idea there. I'm going to go ahead and stop this time lapse. And now what we're going to do is we're going to stop this. I guess I can leave that running in case we need to come back to it. But I want to just show you now, not that folder. I think it's this folder, yeah. So since we don't want to wait 4 hours, I saved my, so everything I just showed you just now, where we're getting all those individual PNG files, drop it in the directory. That's what I did here. I saved these two. Now, the first question you might have in your mind, why do I have 2 separate directories with these PNG files? Well, I will explain that. So the reason that you have 2 is I went through a meridian flip right in the middle of Jupiter, just had to cross the meridian. And that's the reason. I don't know if you noticed in the Jupiter file that I shared, I was kind of bummed out that it was right when the red spot was coming around. I was all excited. I'm like, oh, the red spot is coming. Well, that's right when the stupid meridian flip had to happen. And so I lost, I would say, maybe 5 or 6 frames. It took, it takes a while to recover from a meridian flip and, get your camera back started and everything. So in that video I shared, you see a little bit of a jump, and, I took it into other video software and I put some transitions in there to kind of soften that a little bit. So it didn't look too bad in the end once it was done, but I still was bummed out. But anyway, the point being is that, you could see my telescope here is in a kind of precarious position here, just about ready to, slam into the mount. So the mount wants to flip that over, just like any other meridian flip, and get it over on the other side so that it's moving, further away from the mount rather than closer and closer to it all the time. And so what that means then is, before the meridian flip, I had this orientation of the planet, and you can see Io down here. And now after the meridian flip, the planet's flipped over. Everything is kind of like the mirror image of it. And here's Io over here on top. Now, so I kind of have these 2 different directories of these 2 different orientations. And so part of the first thing you do in pip is to go take one of your directories. Doesn't matter which one you do, but you take one of these sets of files and make them match the other set of files so that all of them are the same orientation. And then once that's done, I moved them all into this combined folder. So now here, all of these files are in the same orientation. And by the way, let me just show you something interesting here. I haven't even created the time lapse yet, but if I click and hold or if I just scroll through this, you notice the shadow moving there? That's Io's shadow. Or if I just click and hold this, and all this is doing is cycling through all those pictures, but you can see it moving already. And I haven't even created the time lapse yet. I'm just simply going through all of these PNG files. I'm just holding down my mouse button here. And it's kind of simulating, giving you a preview of, what your time lapse is going to look like once you've done it. But, we obviously want to do this the right way. So now that we have all those files combined into there, I'm going to minimize this and we're going to go into my Astro software, go into pip, and I'm going to go ahead and add the images. And looks like we're already in the right directory. So I'm going to hit Control A to select all, hit open, and there is the image of the first image of Jupiter. And I'm just going to kind of arrange this so we have a little bit more convenient way to look at it. And then, so the only selection that you have to make here is select Planetary AVI. I experimented with both of these. If you select just Planetary, it still works, but it makes it spin faster. I'm not sure why that is the case, but I think the right selection here is this Planetary AVI that gives it just the right spin. And that's about all you need for that tab. And then for input options, I don't recall selecting anything here. Processing options, I do always select this cropping button. That helps. I don't think it's as much needed now because this data has already been kind of processed and cleaned up. But if you have the planet kind of jittering around and it wasn't as clean, pip will fix that for you. It'll center everything up for you. So part of that is enabling this cropping button. So I think most of the time you'll find you do need that selected. And then quality options, I have not ever really bothered with anything there. This one is all just optional stuff. So for example, you might want I've seen some people do animations where the planet spins one way and then reverses and then spins back and reverse. I don't really like that. And to me, I want to see the planet always moving in the right direction. So I don't do the reverse thing. But one thing I do like to do is, in particular, if you have a short time lapse, maybe you didn't capture enough data, you didn't get the full 4 hours or whatever, it's a good idea to select this because then it'll just replay it. So instead of having a time lapse take 3 seconds, it'll play that 3-second video 5 times over before it quits. So just a couple of options here. These are all just optional things that you can look at and decide for yourself what you want to do. And then this is the format it's going to, I want it to be an AVI, so I'm going to leave that. And then it'll create a little subdirectory for us so it's easy to find the video after it's done. So that little pip subdirectory there is handy. You can put it in whatever subdirectory you want though. And then over here in processing, we just go ahead and start the processing. And you'll be surprised how quickly this goes. This will take 10 seconds or somewhere around there. And then it's going to open the directory for us. There's the directory. And here is our time lapse. And for some reason, I don't know why that is showing in here. Let me get this back. We don't want there. That's more normal size. For some reason, it always shows it blowing up, which makes it look like bad quality. But yeah, that's the time lapse. I mean, we literally just created that time lapse.
Could you go back to the blow up?
Sure.
Thanks.
Video always fit.
Yeah, that looks way better, frankly.
Well, yeah, I mean, that's not the natural. I mean, that's sort of exploded. I don't really, it's kind of spreads out the pixels and stuff. But yeah, it's all preference, whatever.
Well, on
whatever
my
you like.
screen, you can see a lot more than you can with the smaller.
Oh, okay.
Yeah, especially this right here where you can see the moon. That's spectacular. You can't see that so well when it's small.
Yeah, good point. Yeah, it's sort of a give and take. It's it's a preference
I don't
thing.
know.
Yeah.
This part with the moon is more than a give and a take. This other stuff, whatever. But the moon going by with the shadow, that's spectacular.
Yeah,
you're about to see. You're about to there was the meridian flip. This is the part that bummed me out. So you see everything's nice and smooth, and then all of a sudden you see it jump a little bit, and suddenly the red spot is there. So that was the meridian flip. Meridian flip just happened at the worst time. Um, so
Isn't that always the case?
yeah, it sure is. But anyway, yeah, that's how I was doing Planetary, and I in when I do the presentation in April, I'll make this point there too. But I actually think that the traditional methods with AutoStacker and Registacks and all those tools is probably the better way
Hmm.
uh, to do it. You can probably get, if you really, really know what you're doing, though. So that's really the key. If your skill set is very high with that software and you really understand all the features and the placement of the alignment points and all these things that you have to do, you're probably going to get a better result. Someone like Damian Peach, who's a kind of a renowned expert on Planetary, he's going to nail it and probably beat this result. But given that I don't have those skills with that software, for me, I'm getting a better result out of
Well,
SharpCap.
I have heard that Damian Peach gets those results because he uses like professional quality equipment, like 40-inch telescopes and stuff.
Well, that's true, and he's also on the
Aha.
mountaintop. He's on a mountaintop on Barbados as well.
Right. So
So,
I
so
want
I
to
mean,
see him do something with an 8-inch. Then I'll be
yeah,
impressed.
right. No, but my point is if he took this exact SUR file that I'm using, if I gave it to him, and then he processed it through uh, uh, AutoStacker and Register, he's probably going to beat me, because those tools are more powerful and whatever. But my point being is that I certainly don't have that level of skill with those tools, and so this software, gives me the ability to have about 90% of the quality, maybe 95% of the quality that you could get out of those other tools without even, being such an expert in that. So, this is a little bit, this SharpCap is, I kind of correlate it to streaming, if you will. There's a kind of a good analogy, I think, um, because like I said, half the time I don't even save a SUR file. I'm just taking whatever's coming through my telescope and I'm processing it on the fly, and saving these things. So the only reason I have this SUR file is because I knew I needed it for this presentation.
So what size is your scope?
Um, it's the one over my shoulder there.
Right.
It's about an
Diameter?
eight. It's a 8-inch
Oh,
diameter.
okay.
Yeah, and it's 2,700 millimeter focal length. So it's a pretty long focal length. It's very good for planets, um, but not so good for other stuff. So it's more of a planetary thing.
Mm-hmm. Okay.
Um, but yeah, that's what we have there. So I think that is about it. Does anybody have anything else they want covered? Did I catch everything?
So is there a way to do to practice autofocusing indoors when you're not set up outside looking at a planet? Have you
Well,
ever?
that is kind of what we were doing there, but I just don't think the simulation tools are good enough. So I think there is stuff you could do there, but I think you really need, to really do it right. Just pick a night where that's going to be your goal. You're not even going to try to capture any. I've done that a
Yeah.
few times. It's like, it's not such a great night for imaging, so I'll just focus on solving some problem I've been having. And in many cases, it is focusing. I really did struggle with SharpCap's focus there for a while, but I think it was two things. I think my backlash settings were not optimal, and that's where that overshoot really helped me. And that's why I wanted to talk about that overshoot with you guys. I feel like that helps. Uh, and then the other thing was it's very counterintuitive, but with SharpCap, it wants you to take it out of focus first by, maybe 1,000 steps and then start your focus routine. And I don't know other software that really has that requirement, but SharpCap seems to.
Well, that's my frustration is everyone has a ZWO focuser pretty much, right?
Mhm.
And that's what everyone is basically using with the software. And I have never had a automatic focusing problem with the ASI Air with that focuser. But with SharpCap, you got to do all this stuff that is like when the ASI error is so easy, this is just like super frustrating to even have to deal with tweaking anything when it's all software stuff that you think when the pro version would have had all this taken care of. And I don't have the nerve to say that on his forum, but I'm
Yeah.
getting ready to.
Well,
But
but the thing is it once you know what it needs, then it will be easy to you as well. I mean, once you know what it's looking for, then it's routine. You're doing the same thing every session night. And I can tell you, I'm no longer, I was having terrible problems with it too. And once I finally figured out what it needed from me, then
that's the other thing. The ASI error, you don't have to deal with what it's needing. It just does it because that's the thing when the main focuser is the ZWO focuser and Robin, the guy that writes the software, knows this. I just don't understand. Maybe the planets with the contrast edge detection is sufficiently different than stars because I've
oh
never done a
yeah.
planet focus with the ASI error.
Yeah, it certainly is a completely different
It's
criteria.
stars.
Yeah,
But I get
yeah,
the same curve that I get with the ASI error in SharpCap. I see the focus when it's going through its routine. I see where it's perfectly in focus. And then when it finds the focus point, the average, and goes back to what it thinks, it doesn't put it in the right place, which means that I'm probably not going in the right direction.
yeah, it could be. Um,
I don't know.
yeah, there's two things about SharpCap that I think about. With it being just this, I mean, as far as I know, Robin Glover is the only guy running that company. As a matter of fact, he used to do it on the side, and now he's making enough money to where he was able to quit his day job, and now he does that development full time for SharpCap. But it's a little scary, when you think about he's the only one running it. I mean, if something happens and, he decides not to do it anymore, or maybe a health problem or whatever, I don't know who would continue to develop that. So that's something to be aware of. But the plus side of it, though, is he's very responsive. I've read some of his forums where somebody um, made a suggestion about something in his software, and the next day he was already back with a link for a beta copy that they could download. So it's incredible how responsive he is. But then there's that issue that, maybe there's no redundancy either, compared to how Nina works is it's community driven. So there's no like single developer for Nina. It's community driven. So it's not really any fear of losing your developers there.
I got the manual focuser that I use.
Yeah.
So the hand
Well, I
focuser.
tell you what, I look forward to going back through this and taking it in slowly.
Yeah.
A couple of questions related to this. So, if you were shooting the lunar eclipse, this is how you would do it, right?
Yeah, I
L-
think I think lunar is very much the same process as planetary. Yeah, I haven't done a lot of lunar yet. I plan to, but yeah, I
The
think you use a lot of the same concepts.
the the lunar eclipse is going to be a lot dimmer, and you can barely
Yeah,
get a good focus when you have a DSLR going.
DSLR.
So
Yeah,
yeah, so
yeah.
um, all the lunar eclipse pictures I've taken are with my
Gotcha.
Sony A7 on a tripod, and you can get a great focus before and after the eclipse or the moon normally, but with the eclipse, it's so dark that it's all light driven. You can barely, and I think that it's going to be harder to get a focus then, I would think.
Well,
Do you have a lunar eclipse, Russ?
Say that again.
Do you have a lunar eclipse?
What do you mean? Do I have a lunar
A
eclipse?
video of a lunar eclipse
Oh, I do from my um,
with
C star
SharpCap?
from my C star.
Oh,
Yeah, the
well,
yeah,
we're
the Sea
talking about
Star did a
SharpCap.
nice job on it.
Yeah.
Yeah. Um,
So a related question, what about for a comet? Would you use the same thing?
um, I don't know
No,
for a
because
count.
it's deep sky. I use the ASI Air and again the Sony A7 manually with no computer. Have you used the SharpCap on a Comet, Russ?
I've not on a comet. The only time I recorded the comet was with my shorter focal length, the FRA 400 Comet Lemon.
Yeah.
But I think I was using the ASI Air for that one.
Yeah, they're more like deep sky objects, actually.
But are you talking about the processing, Andy? Because I found the processing for the Comet to be very different.
No. Yeah, yeah. Yeah, no, I was just wondering if yeah, I guess Greg's probably right. It's just too dim.
Yeah.
Um, yeah. Okay. Just wondering.
hmm The one thing I wanted to show you, Greg, you were talking about using your hand controller and stuff, and that's certainly
Hmm.
fine to do. But let me just show you something. I feel like I get way better, more granular control through my software, and I'll tell you exactly why I feel that way is because of all of this. Look how many settings I have here. So on my hand controller, I only have two settings. On my AM5, I can press in on the button, and it's fast or slow. That's all I get. And the slow does slow down pretty good. I mean, it's you have some control. It's not bad. But let me just show you, like even 32x here is so slow that if I set that, 32x sounds like a lot, right? Um, but it barely even moves. I mean, you can't even hear it. Like if I hear it, I could I could kind of hear it kicking in a little bit behind me there, but I mean, you're not seeing any motion. Whereas, if I go down here to this is the full speed that's moving 4 degrees per second, and if I hit that, you can see it's moving quickly, full speed there. But all of these settings that I have here, I ended up finding that when I was doing Planetary, 4x was just about where I wanted to be. And that's moving so slow. We're talking like at the level that PhD2 is doing. Just minute adjustments, so microscopic that you can't even detect that the mount is moving. But when you're on a really tight ROI and your planet is, barely fitting inside that ROI, that little bit of movement really shows up there then. And so you kind of want these fine-tune adjustments to keep from overshooting and ending up outside of your ROI when you're shooting the planet. So I find this to be far more granular and more precision control, that I have this many different speed settings versus just fast and slow. But that depends on your mount and depends on your hand
Yeah.
controller. I mean, maybe your hand controller has 20 different settings, just like this does. I don't know. But
Well, it's the Celestron hand controller with like 8 speeds. So
Oh, it does. Okay.
yeah, I use like speed 3 to
Okay.
do my adjustments,
Yeah.
and yeah, I don't track. I do a polar alignment and go to the planet, and then I do normal tracking with the planet stabilization thing turned on, and then I manually do the hand controller to keep the planet in the center of the red box.
Oh, yeah. Speaking of that, I'm glad you mentioned that because this does have that feature too. So under tools, it's called feature tracking. And when you turn this on, this uses so this is not just using the ROI to keep it centered. This is actual guiding on the planet. So you click here, it says use mount, and then you pick your speeds and all that.
Hmm.
And then you click monitor here, and that's where it does the calibration. It reminds you very much of PhD2.
Yeah.
So you're calibrating it. It's checking your RA and your deck and checking how
So
much backslash do you have and all that. Backlash, I should say. And then once that's all set, you click guide, and it will guide on the planet.
So are you saying that you can select this and then when you go to the planet in the red box, it will automatically keep things, the planet in the red box, it'll like guide on the planet instead of a star?
Absolutely.
Wow. So maybe I'm going to do some remote imaging because that's, I have to try that. So
I think
Yeah.
Greg is
thank you
sold
very
on it
much.
now.
Well,
Yeah.
no, if that could be the thing that I've been looking for that I haven't been able to put together. So this is fantastic.
Well, let me blow your mind even more than that, though.
I'm not sure I need that, but okay.
So check this out. I think this is. So I have two versions of PhD2 on my computer. I have my original one, but there is this new version. This is in beta. It's not fully released yet. Uh, and I don't think this is the one. So maybe I executed the wrong one. Let me look for it here. Hang on, just bear with me just a minute. Under my Astrosoft folder, I bet I have it labeled in there. Okay, yeah. See, I see how I have two different copies of PhD2, and you can do this. This is perfectly fine as long as these two copies are installed in separate directories. They won't interfere with each other. You can have them both installed on the same PC. You can switch back and forth between them because theoretically, being that this is a beta copy, it theoretically is not as stable as the other one. So if you want to keep your stable copy here for doing your normal DSO, that's fine. And then when you're doing Planetary, run this one, and let me show you what this has. Um, so this is another way of doing planetary tracking besides what I just showed you inside of SharpCap. So you go to Tools, and you suddenly have this menu option here. You won't see this in the original version of PhD2. You just see it here. And as soon as you click that, you have this option to enable planetary tracking.
Hmm.
And then you create, you decide what radius size it needs to be and all that. And then it will draw a radius, a circle around your planet. So it's guiding on the planet, not on stars, on the planet itself. It'll draw a little radius around the planet and it'll keep that planet, within that radius. So this is another way of doing this. But I'll tell you what I ran into. And I'm not going to bore you with my whole presentation, but I do want to show you one slide that might be of interest to you. Let me see here. I think I'm on the other view. This is kind of odd. Let's see here. Oh, there we go. All I had to do was click that out of there. That was in my way all this time. So let's see. The stack of Jupiter, SharpCap plan. So this is the PowerPoint that I'm going to be using in in the April meeting. So that's going to be kind of different content. We're going to be going through other stuff there that is more, but here I'm talking about the planetary for PhD2. This is the little circle that it puts it in, that Jupiter's inside that circle. But what did I have that I wanted to show you? Let me see here. Where was it? Oh, here it is. So, Planetary takes quite a bit of processing power, quite a bit more than DSO does, because you think about, what it's doing is this fast frame rate. It's got to be able to keep up with that fast frame rate, but more importantly, it also has to be able to write, so it's one thing to, have this fast frame rate, but then can you write that, to your disk at that speed? So, you could have some bottlenecks there. And I remember the reason I'm showing this CPU chart here is when I was doing this, I kind of wanted to use that PhD2 planetary and try to keep the planet dead center so I wouldn't have to babysit it as much. But I noticed that I was already using this much processor power even without it. And I thought, man, if I start lighting up, other software, the PhD2, I don't want to have other software get in the way of the original purpose of the session in the first place. The whole idea is to be able to get a good image of Jupiter and be able to save these files at a fast rate. And, I don't want something that has good intentions to actually turn around and cause a problem. So I chose not to guide that night for this very reason. And this is my little mini PC. So if you look over my shoulder there, it's the little this little PC that's right underneath the front of the scope there. It's a little 12 volt. It does have an N100 processor on it, which is kind of medium for a 12 volt PC. But yeah, you can see here, you definitely have to be aware of the processing power you're taking when you're doing Planetary. So yeah, that's all I wanted to show you there is it's pretty processor intensive.
Fantastic.
Yeah.
Well, thank you, Russ. That was really, really interesting.
Oh, good. I'm glad you liked it. Yeah, I know, we've all been doing a lot of Planetary and everybody's got kind of a different take on it, different approach to it. So it's kind of fun to share these notes with the group. And I look forward to hearing others as well and what they're doing.
And now that we're done, Brian's here.
Yeah,
Better late
just
than
in
never.
time. Yeah.
Well, he can watch the recording.
Yeah.
No, he wants you to do the whole thing over again.
Yeah, come on, start again.
Oh man, I'm getting a dry throat.
Sure.
So that's
No,
where
that was really
come from.
fabulous.
I wondered about that.
My excuse is grandkids, so.
Uh,
So Andy, what is this, week 2 of retirement, right?
yeah, I spent week one and a half with bronchitis. So,
Oh, lovely.
but hey, I've lost track of what days it is basically already. So
You're acclimated.
yeah.
Anyways, apologies, Russ. I would have loved to have been on this, but
Oh, no worries. Yeah.
did you guys talk about that cool new thing called Lucky Stack Worker?
That's for you to talk about.
I'll do it. That's right. I got to do another one. Yeah, I was reading Christopher Go and Damian Peach both endorsed it. So it must be pretty darn good if those two guys did. So that'd be something I want to look into more.
Yeah, and you've already used it once, right? I think.
I processed the last Jupiter using it.
Right.
And I mean, it was. I'm sure you guys went through, WinJupos and derotation and stuff.
No, you actually don't have to do that with SharpCap. Even with a 4-hour long time lapse, you don't have to worry about derotation.
Now I gotta watch the video.
Yeah, this is like one of those things. It's like, how do you do that? But
yeah, that's good.
But yeah, no, it's the reason for that is just quickly, it has this buffer of how many frames that's keeping in it. So the video that we were demonstrating today, it was a 2-minute SIR file that I made just for this demo, and it had 14,000 frames in it, and we were processing 2,000 of those. And so while you have these 2,000 frames going, as soon as you fill that up and you fill up that 2,000, then it starts cycling in new frames on a first in, first out basis. So you never, at no point do you have any frame older than however long that video limit was. So the video, the entire video of 14,000 frames was only 2 minutes. So if you're only doing part of those, so at no point would you ever have more than 2 minutes. So even though you're doing these time lapses over a 4-hour period, none of those pictures are more than 2 minutes old. So that's how you get away from having to do the derotation on the planet.
Got it. Huh, cool.
Yeah. But yeah, it'd be fun to hear what your success was on that. You call it Lucky Stacker.
Yeah, it's really interesting. It's called this guy in I think Finland made it, and it's all one word, Lucky Stack Worker.
Oh, okay.
And it's up on GitHub, and if you look it up, or I can send a link out or whatever.
Yeah.
And
Yeah.
yeah, I've chatted with him, through issues and stuff that I found, and he's very responsive. So
Cool.
yeah, I like the idea of everything being done in one chunk, aside from the initial stacking. But sounds like SmartCap, if you do that right, that's an all-in-one.
It is, yeah. And
Yeah.
and as I was explaining to the group, you really don't even have to save the surf file because you're
Mm.
not processing after the fact. I use the analogy of streaming. It's sort of like almost like a streaming service, if you will. As when you're watching a
Mhm.
Netflix movie, you don't have any hard copy of that movie. You're consuming those bits of data as they come over the wire. And that's a lot. That's a pretty good analogy of how SharpCap is working. You're processing and consuming that data as it comes through your scope.
Mhm.
So there's never a need to save the surf file unless you want to. I mean, you may want to save the surf file so that you can process the old traditional way and then maybe compare both and see, are
Yeah.
you getting a better result out of the older tools or not?
Hmm.
But you don't have to. It's not a requirement. Yeah,
All right, Russ, thank you.
sure.
Can't wait to post this. It shouldn't take very long now that I know what I'm doing. So
Sounds good. Well, congratulations again, Andy, on your retirement. That is so exciting, man. You're a year ahead of me, and I've been counting the days down myself. So
yeah, I'm sure.
yeah,
You can borrow Russ's clock, but I think the clock's retired too.
That's
Or
funny.
not Brian, I mean Brian's clock.
Yeah. I should show those guys the picture. I showed
Yeah,
you.
yeah, yeah.
I had a countdown clock, so I was counting down about a year. And when it hit zero, you should have seen the look on my face.
oh man, God, that's great. Yeah,
All right, everybody. Thanks a lot. I'm going to stop recording.